Righto, g'day folks. I'm going to do a video on what's called binomial products and surds and how the two relate. So I've spoken in the past about how brackets, or what we call brackets, are probably called grouping symbols, because while the symbol is a bracket, what they do is they put the things inside the brackets into a group. So they're grouping symbols. And when you think about what happens to a group, let's pretend we're in times not as strange as what we're currently in now. If there was a group of people next door, and I asked, and you were here in the room with me, and I asked you to look, I want you to go in next door and shake hands with the group next door. And you went through and you shook hands. I mean, imagine crazy times, right? Imagine you could actually shake hands with people. You went in there and you shook hands with everybody. But there was one person who came along and said, no, I'm not going to shake his hand, or no, I'm not going to shake her hand. And then you came back. If I said, look, did you shake hands with the group? Could you honestly answer yes if there was one person in the group that you didn't? The answer is no, you couldn't honestly answer yes. Because to do something to a group means you do it to every member of the group. So you've heard me talk about this in the past when we talk about expanding bracket or expanding grouping symbols out, or expanding brackets. So let's have a look. If I've got 3 outside of x plus 2, well, that means that the 3 is multiplying everything that's inside that group. Right? Make that a bit clearer. 3 is multiplying everything that's inside that group. So 3 is multiplying x to give me 3x. And 3 is multiplying 2 to give me a positive 6. Okay, so this is not new. We've seen this before. We would have seen it starting way back in year 8 even. So what do we do now if there's a surd inside the bracket? Well, we saw this at the end of the last video I uploaded on this topic. Let's say, for example, we're going to look at 5 root 2 outside of 4 minus 3 root 7. Well, what happens now? Well, exactly the same thing. There's a 5 root 2 that's being multiplied by this group. That means that the 5 root 2 multiplies the 4, and the 5 root 2 multiplies the negative 3 root 7. And so we expand them, we multiply them in the normal way that we multiply surds. So 5 root 2 times 4, well, the 5 and the 4 multiply. There's nothing for the root 2 to multiply with the 4. So 5 times 4 is 20. 5 root 2 times 4 is 20 root 2. Okay? And then now 5 root 2 times negative 3 root 7, well, the 5 and the negative 3 can multiply. And inside the radical sign, inside the square root sign, the 2 and the 7 can multiply. So 5 times negative 3 is negative 15, and 2 times 7 is 14. Okay, there's nothing there that I can simplify. There's no square numbers that go into 14. There's no square numbers that go into 2. So that's that question done. Okay, so with that little refresher, let's have a look at binomial products. So binomial, literally 2 number. So 2 number products. I'll wipe this off and we'll start again. Hang on. Okay. Let's say I wanted to look at this binomial product. So I've got 2 minus root 5 multiplied by 3 plus root 7. Well, now I've got 2 groups being multiplied. So I think back to the example I spoke about before. You were in the room here, and I said, look, I want you to go in next door and shake hands with everybody. What about if I wasn't just speaking to you? What about if there was a group of people in the room? There was like not just you and me, but a whole lot of people. And I said, look, all of us are going to go in there and shake hands with all of them, that group there. So that would mean that I'd have to go in and I'd have to shake hands with everybody. you'd have to go in, you'd have to shake hands with everybody, and everybody else here would have to go in next door and shake hands with everybody. So now let's say one of us didn't do that. Let's say one of us said, well, look, I shake hands with everybody, but you know, if there's a teacher in there, I'm not going to shake hands with a teacher. They're always been funny sort of people. Could we say that this group shook hands with that group? No, we couldn't. So everybody in this group has to shake hands with everybody in that group, and then we can say that the two groups, you know, shook hands. It's the same when we're multiplying this group and this group. This says that everything in this group has to multiply everything in that group. So the 2 needs to multiply the 3, the 2 needs to multiply the root 7, the negative root 5 needs to multiply the 3, and the negative root 5 needs to multiply the root 7. So what's that going to look like? Well, look, there's a couple of different ways to set these out, and it really depends on, you know, what appeals to you, sort of, you know, what sort of jumps out, what sort of sticks better in your head. I'm not going to tell you what sticks better in your head. Nobody knows that better than you, so you can work out your own. I'll show you 2 different ways. Okay, one way is the people do is they draw sort of connecting lines. So they go, the 2 has to multiply the 3, and the 2 has to multiply the root 7. And then the negative root 5 has to multiply the 3, and the negative root 5 has to multiply the root 7. So they draw what looks like a giant sort of crab claw, you know, chomp, chomp, chomp across the board. So they draw what looks like a crab claw on the binomial product. And basically what you do then is every line that joins one number with another, you multiply along those lines. So 2 gets multiplied by 3 to give me 6. 2 gets multiplied by root 7 to give me 2 root 7. Negative root 5 gets multiplied by 3 to give me negative 3 root 5. And then negative root 5 gets multiplied by root 7 to give me negative root 7 5 to 35. Okay, there's no like terms in any of that. There's nothing I can simplify, so that's the answer. Now I said there was like a couple of different methods. If you like the the crab claw drawing, fantastic. Let me see if I can line that up with the camera. There you go. So the big giant crab claw going chomp chomp across the thing. If you like that setting out and you want to use it, great. That's fine. I don't mind. Another way that people do it is they do this. So I'm going to do exactly the same question, but just with different setting out. If I want to look at 2 minus root 5 times 3 plus root 7. Now remember, this says that this group is being multiplied by that group. Think about the handshaking scenario, right? If I said, look, everybody, like, pretend it was not just you and me in the group, but in the room rather, but a whole lot of people, and I said everybody in this room was going to go and shake hands with everybody next door. Well, that would be exactly the same as saying, I'm going to go and shake hands with everybody next door. And then when I'm done, now you're going to go and shake hands with everybody next door. And then when you're done, now another person in our room is going to go and shake hands with everybody next door. And then when that's done, and another person in the room. So it'd be like just me shaking hands with everybody next door, and then you just shaking hands with everybody next door, and then somebody, you know, except so on and so forth. Well, look, there's 2 people in this room, and this group is going to shake hands with that group. That would be like the 2 shaking hands with that group. We've already seen how to write that out, right? So the 2 shaking hands with that group looks like this. That means that 2 multiplies everything in there. And then now negative root 5 is going to shake hands or multiply everything in that group. So what would that look like? That would look like this. Okay. So that's negative root 5, you know, shaking hands with that group. And then now here, we're just left with a simple example of what we saw before, what we saw at the end of the last lesson, and what we saw at the beginning of this video. So 2 times 3 is 6, 2 times root 7 is 2 root 7, negative root 5 times 3 is negative 3 root 5, and negative root 5 times root 7, because they're both under the square root sign, we multiply under the square root sign, is negative root 35. Yeah, so it's the same answer in both cases, just a different way to set it out. There's a bit more setting out here, but some people find it actually easier to actually see what's happening with this setting out. So whichever one you like, just as long as you make it obvious to whoever's marking your work exactly what happened in your head for you to end up with the answer that you got. Then if you come across one of these questions that's worth more than 1 mark, well, both of these are, I think, adequate ways to show where they're coming from. A little bit more, just stay with me. Okay, there's a couple of different results with binomials. Now, binomials don't just, this is not the only application of binomials, let me assure you, right? So there's an entire branch of mathematics that if you stick around and you get into extension 1 in year 11 and 12, there's an entire branch of mathematics that uses what's called the binomial theorem. Okay? So there's a heck of a lot to this stuff. We're only just dipping our toes in the water now. So don't sit there and say, oh, this looks weird or this looks strange. I'm never going to need this again. On the contrary, if you want to stick out with this subject, then these are sort of basic fundamental building blocks that you need a mastery of. Not just, oh yeah, I kind of vaguely remember them. You need to master this stuff. So a couple of different results. If I look at a binomial where I've got any two numbers, A and B, they could be surds, they could be rational numbers, I don't care, any two numbers, okay? So A plus B to the power of 2. Well, what does that mean? A plus B to the power of 2 means I've got A plus B being multiplied by A plus B. So look at this, here's a group and here's a group and they're multiplying each other. So that means that A is multiplying A to give me A squared. A is multiplying B to give me AB. B is multiplying A to give me AB in alphabetical order. And then B is multiplying B to give me B squared. Okay, I'll make that a bit bigger. Apologies, I'm drifting off into some small writing there. So what have I got? Let me simplify this. I've got A squared plus 2AB, because there's AB plus AB is 2AB, plus B squared. Now, a lot of people make this very, very silly mistake. They look at A plus B squared and think that's going to be A squared plus B squared. That's not the case, right? A plus B squared, well, there's an A squared and a B squared, but there's also this 2AB. And you can verify that with just simple numbers. If you think about what is 2 plus 3 squared, well, what's 2 plus 3? That's 5. What's 5 squared? 25. So we know the answer here is 25. If you just said it was 2 squared plus 3 squared, if you made that mistake, if you said, oh, this is 2 squared plus 3 squared, well, that'd be 4 plus 9 is 13, not 25. So A plus B squared is not A squared plus B squared. It's A squared plus 2AB plus B squared. Back in the old days, before maths was cool, the way we used to say this was if you had what's called a perfect square, so this is called a perfect square. If you had a perfect square, then to expand it, you squared the first, then you had twice the product, and then you squared the last. So square the first, twice the product, square the last. If that helps you sort of memorize it, then it's a good way to write to think about it. Square the first, twice the product, square the last. So if that helps, and by all means, use that. And it works with positives or negatives. I'll show you an example now with positives and negatives. So if I had, let's actually go to some number examples. If I had let's say 2 plus root 5 squared. Well, let me do that. I'll square the first. So 2 squared is 4. I'll twice the product. Well, the product of 2 and root 5 is 2 root 5. Well, twice that. So in my head, I'm thinking twice 2 root 5. Well, that's 2 times 2, which is going to be 4 root 5. And then square the last. Well, root 5 squared, the square root of 5 squared. Well, square root and squared kind of cancel each other out. So root 5 squared just leaves me with 5. Okay, square the first, twice the product, square the last. And now I can simplify this. 4 plus 5 is 9 plus 4 root 5. What if there was a minus sign in there? What if it was 2 minus root 5 squared? Well, it still works exactly the same way. I square the first, so that's 4, twice the product. Well, now the product is negative 2 root 5. Twice that is negative 4 root 5. And then square the last. Negative root 5 times negative root 5 is positive 5. So that gives me 4 plus 5 is 9 minus 4 root 5. Okay, the exercise, as you work through the exercise, it'll lay up some nice and easy ones of these for you to get into it anyway. Okay, so that's what we get when we expand a perfect square. And it wouldn't matter if there was 2 surds. So if I had root 3 plus root 2 squared, I do it exactly the same way. So square the first. Root 3 times root 3 is 3. Twice the product. Root 3 times root 2 is root 6. Twice that is 2 root 6. And then square the last. Root 2 squared is 2. And just 3 plus 2 is 5 plus 2 root 6. Okay, so it doesn't matter if they're rational numbers or surds. Expanding these perfect squares always works that way. Okay, I did say 2 more things. Now that we're down to 1 more thing to show you. So you can pause the video to get that down. I don't need to wait for anyone to copy that down. Okay, so we saw what happened in what was just on the board. We saw what happened when we had A plus B times A plus B. Or A plus B squared. We saw what happened then. What happens when we've got what's called mathematicians love to give names for things, they really do. It makes them feel like they're really smart. What happens when we've got a thing called a conjugate pair? What's a conjugate pair? Really simple idea. A plus B times A minus B. So both groups are the same, except one's got a plus, one's got a minus in the middle. Right? What happens then? Well, let's expand this and see what happens. So let's do that. This guy shakes hands here and that guy shakes hands there. Like that. So what happens then? A times A gives me A squared. A times negative B gives me negative AB. B times A gives me a positive AB. And then B times negative B gives me a negative B squared. So look at this. I've got a negative AB and a plus AB. Well, they're going to cancel each other out. And so I'm left with A squared minus B squared. So here's another important result for us. A plus B, A minus B, is A squared minus B squared. So this is called a difference of 2 squares. A difference is, you might remember from primary school back, if you were fortunate enough to be back there when they taught mathematics. Just jokes, folks, just jokes. Difference means is the result of subtraction. So there's a subtraction here. So this is a difference of 2 squares, A squared minus B squared. Okay. So a plus b times a minus b is a squared minus b squared. Okay. It gives us a difference of 2 squares. This is a useful result. Later on, it's going to come up in reverse. So down the track, you're going to see it as a squared minus b squared is a plus b times a minus b. But don't worry about that for now. That's just like that's obviously true, right? Because if this is the same as that, well, that means that that is the same as that, and that's what I've written down there. But look at that result there: a plus b, a minus b is giving me a difference of 2 squares. Square the first minus square the last. Okay. Let's look at an application of that, or a couple of applications. So if I've got 2 plus root 3 times 2 minus root 3, well, straight away I look at that and I think, hang on a second, that's a difference of 2. They are a conjugate pair. They're a conjugate pair. They're both the same. They only differ by the sign in the middle. Well, I know that that's going to be a difference of 2 squares. It's going to be this guy squared, well, 2 squared is 4, minus this guy squared. Well, root 3 squared is 3. So that equals 1. Okay, so 2 plus root 3 times 2 minus root 3 equals 1. You could conceivably, walk up to, it's going to have to be a takeaway place now, but you could walk up and say, look, I want 2 plus root 3 times 2 minus root 3 hamburgers, please. You just want 1 hamburger. Try that. Let me know how you go in the comments. I'd love to hear your experiences. It doesn't matter if that's rational and that's a surd. It can happen if you've got 2 irrational numbers, or So I might have, for example, 2 root 5 plus 3 root 7 times 2 root 5 minus 3 root 7. It doesn't matter how neat or tidy or how ugly what's in my grouping symbols are. It always works out the same way. They're a conjugate pair. They're both the same. They only differ by the sign in the middle. So when I expand these, I'm going to get a difference of 2 squares. I'm going to get now. I'll put in an extra step so we can see what's happening here. I'm going to get this thing squared. So I'll actually write down 2 root 5 squared. So I'm not just going to write out what the answer is. I'm just going to say that we're going to get that thing squared. We'll work it out in a second. Minus this thing squared, 3 root 7 squared. Okay. Well, what's 2 root 5 squared? Well, that's 2 root 5 times 2 root 5. So in our heads we think 2 root 5 times 2 root 5. Well, 2 times 2 is 4. And root 5 times root 5 is 5. So this is 4 times 5. 2 root 5 squared is 4 times 5. Minus, same deal with 3 root 7. It's going to be 3 times 3 times root 7 times root 7. So 3 times 3 is 9. Root 7 times root 7 is 7. Okay, so that's 20, take away 63, that's negative 43. Okay, so guys, that gives you a fair bit to do. I'm just checking the exercise number. It's exercise 2D. Exercise 2D. I'd really like it if I had lots and lots of good feedback saying that, yes, thanks Mr. Obeid, or thanks Obeid, I understood this, or I don't really know what's going on here, can you explain it? Don't just leave me in the dark, guys. This new medium is not just new for you, it's new for me too. You've got to tell me. I need some feedback from you. I need to know if you're understanding what's going on, if you're struggling with what's going on. I'm here to help you. Even better, if you don't want me there to help you, I'm not there, I'm over here and you're over there, okay? You're out there and I'm here. So I can help you by distance. It doesn't, you can jump on the Maths Online, find explanations of the same work, but please give me some sort of feedback. If I don't start getting feedback soon, I'm going to have to start getting on the phone to mum and dad and saying, look, is junior or juniorette actually doing any of this work, and to chase it up. You don't want me to sort of do that. So how about you guys get in touch with me and let me know how the work's going. I don't want to get to the point where I make a mandatory, you've got to take a photo of the work you've done for that day and email it into me. So let's just communicate. Thanks, guys.